Hi students, it's Mr. Kaczynski. I've got your solutions to the Chapter 6 test. A lot of exponent stuff here. Starting off with some simple exponential expressions here that we're being asked to basically simplify. Alright, so first one, 48x to the 7th, because 24 times 2 is 48, and x to the 5th times x squared is x to the 7th. I know that when you're multiplying numbers with the same base, x and x, that we add the exponents 5 and 2. Second one, 5x cubed y squared all squared. Alright, well, we have to square everything that's inside of here. So 5 squared is 25. X cubed squared is x to the 6th, because I know that when I'm doing a power to another power, I multiply those powers. 3 times 2 is 6. And y squared is y to the 4th, because 2 times 2 is 4. This one here is 24x to the 5th, because 72 divided by 3 is 24. And x to the 6th divided by x is x to the 5th. Again, I know that when you're dividing numbers with the same base, x and x, that I subtract their exponents. 6 minus 1 is 5. Simplifying this, we had something like this show up on a quiz. 3 to the z, there's nothing else with a 3 as a base, so I'm going to leave it alone. There are 2 items with 5 as a base, so I'm going to write that as a single base of 5, and I'm going to add the exponents x and y. Those are not like terms, so you have to just leave it as x plus y. E, we start to get into the uglier ones here, so let me show you my first step, which actually has kind of multiple steps going in it. First of all, 3 times 5 is 15. X squared times x to the negative 4 is x to the negative 2, as in 2 plus negative 4 is negative 2. Y to the negative third times y to the third is y to the 0. Negative 3 plus 3 is 0. And y to the 7th times z to the 7th times z to the negative 12th is z to the negative 5th, because 7 plus negative 12 is negative 5. Down at the bottom, all of this cubed. So 3 cubed is 27. X cubed is x to the 9th. 3 times 3 is 9. Y to the negative 2 cubed is y to the negative 6. Negative 2 times 3 is negative 6. And z to the 5th cubed is z to the 15th, because 5 times 3 is 15. If I'm going too fast, you can pause, you can replay. That's the point of the video. Alright, as far as 27 or 15 over 27, that fraction can be simplified to 5/9. 15 divided by 3 is 5. 27 divided by 3 is 9. X to the negative 2 over x to the 9th is x to the negative 11th. Negative 2 minus 9 is negative 11. Y to the 0 divided by y to the negative 6 is y to the positive 6. 0 minus negative 6 is like 0 plus 6. And then z to the negative 5th divided by z to the 15th is z to the negative 20th. So I'm not going to leave that there, though, because I don't want any negative exponents. Make that all into a single fraction. I'll leave the y to the 6th on top. And the x to the negative 11th and z to the negative 20th, we can move those over to the bottom and make their exponents positive. We learned that by doing some IXL. Alright, this is a two-step problem here. I'm going to cube everything that's in this first set of parentheses. 3 cubed is 27. X to the 7th cubed is x to the 21st. And y cubed is y to the 9th. I didn't change anything here. Then I'm multiplying. 27 times negative 12 is negative 324. X to the 21st times x to the 4th is x to the 25th. Y to the 9th times y to the 1st is y to the 10th. I'm done. And then this one, G, the first thing I notice is that everything in the parentheses is the same. So these two expressions have the same base, the numerator and the denominator. So let's write it as that base with a single power. So I'm doing 1 minus negative 5 is positive 6. This is raised to the first power. This is raised to the negative 5th power. They're being divided, so I can subtract their exponents. 1 minus negative 5 is positive 6. Then I can raise everything inside the parentheses to the 6th power. This is not the only way to do this, but for me, it was the easiest way to do it, and you probably agree after you've seen it if you took different routes. Negative 2 to the 6th is 64. As in negative 2 times 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 negative 2. X to the 7th raised to the 6th is x to the 42nd. Y to the 3rd to the 6th is y to the 18th. And z squared to the 6th is z to the 12th. Alright. Use the properties of exponents to answer each question. Explain why x to the fifth divided by x to the fifth is 1. And I can't just say any number divided by itself is 1. That's not using properties of exponents. So here's where I'm going to start. When dividing numbers at the same base, subtract the exponents. So x to the fifth divided by x to the fifth is x to the 0, because 5 minus 5 is 0. Then I could say something like this. Since any number raised to the power of 0 equals 1, a to the 0 must equal 1. If you brought like a to the m divided by a to the n equals a to the m minus n, and then on this one a to the n, I'm sorry, a to the 0 equals 1, you know, if you talked about those properties, I mean, I just said it in words. Hopefully that makes sense. And then write an equation equivalent to y equals 1 over x to the 10th. I mean, there's other things we could do, but the one that jumps out at me is y equals 10 to the negative x. Those are equivalent equations. In fact, let's go ahead and graph them, and I'll show you. (10 to the power of negative x) and 1 over 10 to the power of x. Let's graph these things. There's the first one. And you're not seeing a second one show up because they're the same thing. Let me prove it to you by going to the table. There's the table. They're both the same. A rubber ball rebounds to 85% of the height from which it is dropped. Okay, how high is the first bounce? Well, we basically want to know what 85% of 200 is, and it's 170. Record the height of each bounce in the table. So what I did was do a recursive formula like this. So 200 times 0.85 is 170. And 170 times 0.85 is 144.5. I rounded it to 145. You hit enter again. 145 times 0.85 times 0.85 times 0.85. These are all rounded values, but on this recursive formula, I just kept hitting enter a few more times, which actually is what is being asked of us here on C. Write a recursive rule that generates the heights of the bounces. Well, there's my starting amount, 200, enter, and here's my rule. Multiply that number times 0.85, enter, enter, enter. Kind of used that rule already. Write an equation that generates the height of the bounces. Okay, here's my starting height, 200, and times 0.85 to the power of x, where x is the number of bounces and y is the height at bounce x. And on which bounce will the height first be less than 70? So I went ahead and entered the equation into my calculator, went to the table. You can see down here in the 7th bounce, that's the first time it's less than 70. So my answer is the 7th bounce. Write an expression in this form to answer each question. So I'm not actually simplifying the expression. I'm just going to leave it there. Otherwise, I could do these with a recursive formula, and I actually wanted to see your expression. If a painting is worth $5,000 today and is increasing in value 7% per year, how much will it be worth 3 years from now? Okay, so there's its worth today, $5,000. It's increasing, so plus 7% each year. And we want to know 3 years from the 5,000 what it'll be worth. There it is. I don't need to simplify it any more than that. B, if a car was valued at $12,000 7 years ago and is decreasing in value by 20% per year, what is it worth today? Okay, so I've got its value 7 years ago. I've got that it's decreasing, subtracting 20% each year. And it was 7 years ago, so I'm going to need to decrease that 20% 7 times, so to the 7th power, to find out what it is today. If a house is appraised at $180,000 today and has been increasing value by 11% per year, what was it worth 5 years ago? So now we're going back in time. So I've got what it's worth today. It's been increasing in value by 11% per year, but I want to find out what it was 5 years ago. That's why we've got the -5 right there. and this one's similar. If a certain investment is valued at $50,000 today and has been decreasing in value by 0.5% per year, what was it worth 20 years ago? Again, we're going back in time here. That's why the negative exponent, 20 years ago. And it's been decreasing by 5%, 0.5%, and this is its value today. Write each number in standard notation. So we got negative 4.3, and we're going to multiply that by 10 5 times. Okay. If you multiply it by 10 once, it would be negative 43. By 10 twice, it would be negative 430. By 10 3 times, it would be negative 4,300. There we go, after we multiply by 10 5 times. And this one is actually being divided by 10 4 times. So if you divide by 10 once, it would be 0.525. By 10 twice, it would be 0.0525. There it is, divided by 10 4 times. Writing these numbers in scientific notation. Okay, so 3.154 are the digits we're going to keep, and we would need to multiply that by 10 times. And I can just count the digits to the right of that 3. Here's 3 plus 3 plus 3 plus that 1, so that's 10 digits. Similar idea here. I'm going to keep the negative 0.502, but actually I would have to divide by this number by 10 6 times to get this number that I originally had. 1 2 3 4 5 6 places that the decimal would have to move. On C, we can use the properties of exponents with our scientific notation. So 1.4 divided by 2.8 is 0.5, and 10 to the 14th divided by 10 to the 16th is negative 2, but that's not scientific notation. So I would have to multiply this by 10 to get 5, divide this by 10 to keep everything balanced, and we'll get the negative 3. D is similar. 3 times 3.3 is 9.9. 10 to the 7th times 10 to the negative 4th is 10 to the 3rd. That's in scientific notation. So I'm done. Last set of problems here. Let me go full screen on this one. Alright, so I mean basically we've got a number in standard notation. We're being asked to turn it into scientific notation. So what would its exponent be? It would be negative 4, as in 1, 2, 3, 4 times that I would have to divide by 4. This one I decided to look at a little bit different. Like, to get 25 turned into 2.5, I'm dividing it by 10. So to keep this expression equivalent, I should take 10 to the negative 5th and multiply it by 10 to keep everything kind of balanced. So 10 to the negative 5th times 10 to the 1st, I would add the exponents. So negative 5 plus 1, that's 1 right there, would be negative 4. And again on C, it's just turning this number into scientific notation. It's really not much different than E, negative 3rd, because we have to divide by 10 1, 2, 3 times. Alright, I know I was talking fast at times. If you need to re-listen to anything, please rewind. You can always pause and write down notes as I'm going. And hopefully this helps if you need to come in and do a retake. Good luck.